Welcome, class, to the Intro to Java Programming. In this lesson, we will review the keyword static, the different static types, and where they exist in memory. We will also cover some rules and guidelines, when to use static, and see some code examples. Junior level developers will often improperly use static because it is very easy to work with, or they avoid it altogether because it is confusing. Static is a necessary keyword that will be used in every project. Let's examine how to properly use static and remove all the confusion. Static is a keyword used mainly for memory management of properties, methods, code blocks, and nested classes inside a class. It allows access to static members of the class without creating or instantiating an object of the class. There are three important items in this definition needed to better understand the term static: memory management, static member, and instance of a class. The following example is intended to be a general understanding for beginners and not exactly how memory management works. Please do additional research if interested. Inside the computer is a big area of memory available for everything. This area holds the code for the application, including the classes. This area holds the variables and other things created by the application. One of those variables could be a new object created from a class. When a new object is created, it is considered an instance of a class, or instantiated. You have created or instantiated several classes in prior lessons. One example is black dragon equals new dragon. Here, in this portion of memory, the application has only one dragon class. The new black dragon object variable is stored in this portion of memory. There could be 0 to many dragon object variables created from the dragon class. Just remember the class is in one portion of memory and the object variables are in another portion of memory. Static members are fields, methods, code blocks, and nested classes. I will discuss each type in more detail later. For now, it is important to know where they exist in memory. Static members belong to the class and exist in this area of memory. They are identified with the keyword static and, with the proper access modifier, are always available to all classes and objects. Static members are accessible directly from the class. Properties, constructors, and methods are not accessible directly from the class, only from the instantiated object. Instance members are located in this area of memory if instantiated. They are the properties, constructors, and methods of the instantiated object and are accessible with the proper access modifier. This means the dragon class could have a static property called monster type and is equal to dragon. All these dragon object variables have a monster type property equal to dragon. The actual value is stored in memory here, inside the class. All the instance objects have a pointer to the static member in the class. So if the monster type value is changed, all the dragon object variables will reflect that change. Remember, the static members belong to the class, not the instance of the class. There are 4 types of static members: field, method, block, and nested class. The static field is also known as a static property or static variable of the class. This is similar to the property of an instance, except the static value is stored here, and the non-static instance property is stored here. The static property looks like this in code. There is an access modifier, the keyword static, and a data type and property name. Typically, the name is in all uppercase letters with an underscore separating each word. Here is an example of getting the value of the static property from another class. The string variable actual will hold the result. Dragon is the name of the class. Monster type is the name of the static property. Remember, the dragon class does not need to be instantiated to get the value from the static property. The static method is similar to an instance method. Again, the static method lives here, and the non-static instant method lives here. The most popular static method is main and will be covered in the next lesson. The static method looks like this in code. There is an access modifier, the keyword static, and a return data type and method name. Any parameters will go inside the parentheses, and the code is inside the curly braces. Here is an example of getting the value from a static method. The string variable actual will hold the result. Dragon is the name of the class. GetMonsterType is the static method that will return the result. A static block will immediately execute after the class is loaded into memory. The static block looks like this in code. There is only the keyword static, no access modifier, return data type, block name, or parameters. There are curly braces that hold the code to be executed. This code block cannot be called by any class. A static nested class is a class inside a class. The outer class cannot be static. The inner or nested class can be static. The code looks like this. Notice the keyword static between the access modifier and the class keyword. Inside the curly braces can be properties, constructors, and methods, both static and non-static. Nested classes are advanced and infrequently used. Look for a Coach Joe workshop on nested classes. Be sure to follow all the rules of encapsulation. Also, for all static members, please follow these rules and guidelines. Imagine there is a single class. This class has two public properties, one static and one non-static, or an instance property. There are two public methods, one static and one non-static, or an instance method. Time for a Coach Joe challenge question. Can a static method change the value of a public non-static property? Correct. The instance property does not or may not exist. The most important rule or guideline to remember is static members cannot directly access local instance members. Static members always exist in memory here. Instance members only exist in memory over here if an object is created with the new keyword. The instance member does not exist here. Since it's possible the instant member has not been created, it's a compiler error if the static member tries to access it. That includes properties, methods, the keyword this, and the keyword super. Static members can directly access local instance members with an object reference. This means if the static method creates the new object or object reference, then it can access the instance member with the proper access modifier. Static members can access other local static members regardless of the access modifier. Let's talk about some rules and guidelines between two classes. Static members can access static members of another class with the proper access modifier. Static members can access other class instance members with the proper access modifier by using an object reference. With inheritance, if the parent class has a static method, the child class cannot override the method. The last rule or guideline is, instance members can access all static members with the proper access modifier. Static members are useful and powerful. However, junior-level developers will frequently overuse or improperly use static members. Senior-level developers will restrict the use of static to specific situations. Consider these basic guidelines. Instance members can access static members. Static members should not access instant members with a few exceptions. Static members should not access other static members with a few exceptions. Because static members can be available to all classes and objects, it's important to use them for good, not evil. Here are some good situations for using each static member type. Limit the use of a static field or property to a read-only value needed by many classes. This property will be public and final, meaning the value cannot be changed. Limit the use of a static block to the assignment of a complex value for a static property. Use a static method for main, which will be covered in the next lesson, or when a method does not use or modify existing data and the result depends on the parameter values passed in. Use of a static nested class is more advanced and also infrequently used. Look for a Coach Joe workshop on the builder pattern. The nested static class is shown here. Let's start a new project in IntelliJ. I will be creating a new Maven project. Use the name First Program. Enter an artifact ID, click Finish to create the project. Let's create a new Java package called Static Members. Let's create a new class called Dragon Static. There are two properties, one static and one non-static. Here is a constructor used to populate the non-static property. Here is a static block used to populate the static property. There are 4 methods, 1 static and 3 non-static. Let's look at the test code. Let's create a new test package called Static Members. Let's create a new class called Dragon Static Test. This test will verify the static block populates the static property without instantiating the Dragon static object. Let's run this test. And it passes. This test will verify access to a static method without instantiating the Dragon static object. Let's run this test. And it passes. This test will verify that multiple instances of the Dragon static class share the same static property value. 3 instances are created. Each instance will get the value from getMonsterType and assert the value is equal to Dragon. Back in the Dragon static class, the getMonsterType method returns the value of the static property. Let's go run the test. And the test passes. All 3 instances share the same static property value. This test will verify a change to the static property value is seen by all instances. 3 instances are created. This assert verifies the initial static property value is Dragon. Here, the static property value is changed. These asserts prove all 3 instances see the change. Let's run this test. And it passes. This test is similar to the previous test. The only exception is the static property value is changed with a method call from the instance. Back in the Dragon static class, setMonsterType from the red Dragon instance will change the static property. Back in the test, these asserts prove all 3 instances see the change. Let's run this test. And it passes. Let's create a new Java class called staticOuterClass. This code will show accessibility of nested static classes with other properties and methods. Take a little time to review this code and make some additions or changes to better understand. These 2 lines prove the static nested class cannot access non-static properties of the outer class or inner nested class. Let's comment these 2 lines. Let's create a new Java class called AllowedStatic. This code will show several allowed uses of static members as described earlier in the lesson. Just because these commands are allowed does not mean they are all recommended. This method shows how an instance method can use several static properties without instantiating the objects. This shows many allowed commands from a static method. Access to a local static property, accessing local members with an object reference, access to another class static property, accessing other class members with an object reference, and access to static members of a static nested class. Let's create a new Java class called staticInheritance. This class is needed for an inheritance example. There is only one static method. Let's create a new Java class called NotAllowedStatic. This code will show several examples not allowed by static members. Inside this static method are many common mistakes. Here, access to local instance members are not allowed, including the keyword this. Here, with the use of an object reference, private members of another class are not accessible. And here, accessibility issues with members of a nested class are shown. Finally, a child class cannot override a parent static method. Here's a summary of all the test code we wrote for this lesson. You should now have an understanding of the keyword static along with the 4 different static types. Static members exist in a different portion of memory and are always available to all classes and objects provided they have the proper access modifier. Many rules and guidelines were covered along with preferred uses of each static type, including code examples. In the next lesson, we'll discuss static main. Remember, future senior developers, make it work, prove it works, then make it better. Ready?
Break!